easy because the first part of the lesson is just what's called systems of inequalities. So we've learned how to solve a system of equations, right? Here's an example, by elimination, substitution, and graphing. When we solve a system of equations by graphing, we're finding the one xy point where they intersect, right? All right, now the only difference is when we solve a systems of inequalities, instead of an equal sign, now there's an inequality, there are multiple solutions. Anything that falls within the shaded region is a solution. So you'll see what I mean by that in just a second. Oh yeah, so notice in this picture, guys, do you guys see how it's the same problem twice? This one just is the intersection point where this one is all of the shaded region. So what ended up happening was I get y is greater than on both of them, and so then I've shaded above both the lines, and so then this is the intersection. Any point that falls in this highlighted region here would be considered a solution. Okay, let's review a couple things. We have learned this type of stuff before. So if we have an inequality with an equal sign, we have a solid line, and that would mean that any xy point that falls right on the solid line is a solution. Sorry. If you have y values is greater than, not equal to, it's a dotted line, and any xy point that falls right on the line would not be a solution. We know all this already? Okay. Moving on then. Okay, let's review how to shade correctly. This is always the hardest part for people. So everybody watch pretty carefully and make sure you ask questions if you don't get what I'm saying. So this, we're even told the equation y is greater than or equal to x squared. So here's our x squared. Notice it's a solid line because it's equal to, right? Now, our solutions are any y values that are greater than the quadratic. Does everybody see how that reads? So that would be above the quadratic. This is greater than the quadratic. Now, if you didn't know that, then you could do some math to figure out, well, where should I be shading? So let me show you a trick, another way of figuring out if you've shaded correctly. What you could do is go plug in an xy point to see if it truly is a solution in the shaded region. So like, let's plug in over 0 up 1. Isn't that a point in the shaded region? Plug it in and see if it's a true statement. So this is an xy point, so that would be 1 is greater than or equal to 0 squared. 1 is greater than or equal to 0, which is true. If you were to plug in a point out here, you would see it's a not true statement. Does that kind of make sense? Okay, let's shade this one. X squared minus 5, so here's our quadratic. It's not equal to, so it's dotted lines. This says shade the y values below the quadratic because it's less than. Y value is less than the quadratic, so that would be all of these below it. Does that make sense? Okay. Let's do the line one next, then we'll go to the circle. So this says y values greater than the line. So that says y values above the line. So isn't a greater than the line above it? So that'd be like up here on this one. Okay, now with this one, we have to remember how circles work first of all. So what this says is x squared plus y squared is less than radius squared. So our center is at 0, 0. And our radius squared is 25. Therefore, our radius is 5. Over 5, up 5, over 5, down 5. And then I've drawn in my circle. So what this says is we have our solutions are in the circle below the radius of 5. So isn't outside of the radius of 5 would be greater than a radius of 5, right? Below, less than a radius of 5 would be inside here. Because all of this is less than a radius of 5. Now what if you, once again, were like, I'm not sure. Then go plug in a point. Look, let's plug in the point 0, 0, and plug it in, x, y. Let's see if that's a true statement. Is 0 squared plus 0 squared less than 25? Yes, so that point was in the solution set. So you're probably shading on the inside then, right? Make sense? Okay. So if you ever question it, plug in a point, see if you've shaded in the correct region. All right, let's review how to graph these things, guys. With quadratics, we all know how to graph a quadratic. First of all, I'm not going to make it any more complicated than it needs to be. Make an XY chart, plug in points. Plot the points, make it a perfect quadratic that will fit the graph perfectly. Pretty easy. I don't need to go over that, do I? Okay, then let's talk about how to graph a circle one more time. We would have a center here. There's no shift left and right, no shift up and down. So my center on this would be 0, 0. My radius squared is 25, therefore my radius is just 5. So I'd start at 0, 0, over 5, up 5, over 5, down 5. Connect my circle, right? Okay, so what would the center be here? because this is equal to radius squared. So radius squared equals 25, square root it, you get 5. So right here, what's my center at? Good, right one, and so it's actually down 2. So if they're both in parentheses, they're both going to be opposite, just recall. So this would be over 1, down 2, and then our radius is 4, isn't it? So I go out 1, 2, 3, 4 units, same thing, up 4, over 4, down 4. And then I would connect my circle. Okay, are we good with graphing circles? Okay, sweet. Moving on to actually doing some math here. Okay, let's see if you can work backwards, because there's a good chance on the homework and stuff that they give you a problem like this. It says, given that the line is y is equal to x minus 2, write an inequality with this solution set. So what would be the true statement here? Our y values are less than x minus 2. Okay, good, because it's not equal to, so it's not equal to, and then it's below. Okay, right here, this would be y values greater than or equal to true. Now our circle, we don't write y equals 2. This is the only time we have x squared plus y squared and we leave it as is. So we would have our x squared plus y squared is less than 4, because it's inside the radius of 4. Okay, good. You guys get that. Okay, let's just see here. These first few examples, like I said, you really do not need to take notes. Watching, you're going to get more out of it because you know how to do all this stuff. I'm just reminding you of a quick couple things. So first of all, you would say this is a circle. Equation number 1 is a circle. So I write a note. My center is at 2, negative 1. My radius is 3. That's the first thing you would do. Over 2, down 1, out 1, 2, 3, up 1, 2, 3, over 1, 2, 3, down 1, 2, 3. Solid, you tell me, oops, down 1, 2, 3. Solid or dotted line? Solid, because it's equal to. So I'm drawing it as accurate as possible. Obviously, it doesn't need to be perfect. Moving on here. Now, oh wait, I'm going to write myself a note while I'm here. Should I be shading in a minute? I'm not going to do it yet. On the inside or outside of the circle? Yeah, because it says shade on the circle greater than a radius of 3. So outside. So I'm going to write myself a note. Outside of the circle is the shaded region. Okay, moving on to number 2. It's a line. We would want to get it into y equals mx plus b form. Subtract x. Rewrite it in the correct order. Negative x plus 1. You have to know how to graph a line. Y-intercept of 1. Slope is negative 1. So down 1 over 1. Solid or dotted line? Is it equal to? Oh, crap. There wasn't even an inequality on this one, is there? Because they're supposed to be. It was a typo. Let's go like this. Less than or equal to. So, still a solid line. But now, are we shading above or below that? Below. So I just write myself a note. Now I'm going to fill in where the intersection of that is. If you're shading on the outside of the circle and at the same time below purple, can you see where you would shade? You can? Would it be here? Yes. Good? Easy. This stuff's easy. Okay, well, a couple more here, and then we'll get to the stuff that's just a teeny bit more thought process invoking. So, equation number 1 is a line, get it into y equals mx plus b form. So the first thing I do is subtract x. 3y is less than or equal to negative x plus 12. Divide by 3. So y value is less than or equal to negative 1/3 x plus 4. So I'm at 4, down 1 over 1, 2, 3, down 1 over 1, 2, 3, and up 1 over 1, 2, 3. Okay, solid or dotted, you tell me. Another solid? Shading above or below? Below. Okay, next one, graphing the next one, it's another line. So we're going to get y is less than or equal to negative x plus 8. So down 1 over 1. Solid line again, right? And we're shading below. Okay, now this one, it says all of your x values are greater than 0. So won't that be, x values have to be greater than 0, yeah? Am I recording? Is it going? Okay, good. So I'm going to just block this off. Guys, isn't this going to be x values greater than 0? To the right of this? And then any y values also have to be greater than 0. So then won't that restrict us just to quadrant 1? Y values down here are negative. You guys see what I'm saying? Y value is greater than 0 and X value is greater than 0 would restrict us to quadrant 1. So now there's our shaded region. It's got to be below red and below purple and in that restricted zone. So this would be our solution set, right? Okay, cool. Okay, another one real quick. So we have a circle, radius of 3. And then we have a quadratic, so I would subtract 2x. So I have y squared is greater than or equal to negative 2. Oh, it's not a quadratic. Negative 2x plus 1. Uh-oh, good catch. We better hurry and fix that. So dotted, better make it dotted. Okay. Let's see if this is better too. Okay. Now I can't see my circle. Okay. All right. All right. And then, oh, wait. Were we going to shade above or below that? Inside. Sorry, my bad. Inside. Sorry. All right. Then, once again, back to here. Wouldn't we square root both sides? Well, if that's true, guys, then we have to not forget a plus or minus. So we have y values greater than or equal to plus and minus the square root of negative 2x plus 1. Now, everybody, what you're going to do from here is just plot points. Let's not make it harder than it needs to be because that is a little bit of a complicated graph. I mean, somewhat. So I need everyone, this is where I need your calculators out handy because it's going to take us a while. I'm going to plug in some xy points. Now, I've got to make sure I plug in plenty of xy points here. So the hard thing is people don't know where to start. Now, look, let's say you tried starting at 0. Let's say you tried starting at... Yeah, 0. Okay, what would you do naturally? Where would you start if it was you on the test? You'd probably start at what? 0? Okay, I'll put that in the middle then. Okay, so what do we get? Plug in 0, guys, and you get plus or minus the square root of 1, which is plus and minus 1, right? So you actually get 2 points here, plus and minus 1. So now I can graph that point. Over 0, up 1. Over 0, down 1. Now what I was going to say is actually, like, technically, don't we kind of want to know our domain? Because then we know what we can plug in. So let me just show you something. Negative 2x plus 1 needs to be greater than or equal to 0. Isn't that true for a square root function? So subtract 1, so we would have negative 2x is greater than or equal to negative 1. Then divide by negative 2, so I got to change my inequality sign. So x value is less than or equal to, then isn't that 1/2? So we're actually starting at 1/2, and then we can do any value below 1/2. Does that make sense, everyone? Because that kind of helps you know where your starting point is. So I'd find the domain if you have a square root real quick. So I'm going to put in 1/2 here. Sure, let's plug in 1/2. So if we plug in 1/2, don't we get 0? Okay, so that'd be like our vertex. So over 1/2 of 0. All right, so now let's plug in a value below 1/2. 0, below 0. Negative 1, then let's jump and give us some, just so we can fill in this graph, let's jump to like negative 5, and then let's jump to negative 8. So everybody take one, calculate it, give me the decimal. So if you plug in negative 1, you would have the square root of 3. Square root of 3. So just give me the decimal of that. Good. Plus or minus 1.7. Okay, so I'm going over negative 1 down 1.7, over negative 1 up 1.7. Okay, I'm seeing my sideways parabola. Let's plug in negative 8 next. Let's just skip to negative 8. Let's just get right to it. Sorry, positive or negative 4.1. The reason I like this one is because it didn't come out pretty, and you got to still be able to do stuff on the test that kind of feels weird. Does that make sense? So we're making do. So we're going to negative 8 up 1, 2, 3, 4.1 units, over to negative 8 down 1, 2, 3, 4.1 units, and now do you guys see how I can connect it? Solid line. Now what are we shading here? Let's look back to here. Y values greater than or equal to this this square root. Now, if you're confused, where should you be shading? Couldn't you just plug in an XY point? Isn't 0, 0 inside? Let's plug in 0, 0 and see if I'm shading in here or out here. So plug in 0, 0 right here. And we would get, is 0 greater than or equal to 1? No. So we must be shading on the outside. Do you guys see? Because it was no on the inside. So outside. Okay, so where would that be? Can you guys see it? Inside the circle, at the same time outside of the square root. That's plus and minus. Okay, that was a good one to do, just because it's it wasn't very pretty, that is. Sweet, you guys are doing good. Okay. All right, so I don't think you probably need to see this one, but just making sure here, if we would have a quadratic, so I'll just do a rough sketch here. Okay, we have a quadratic, and then we would have a straight line at 4. Now, is it a this line or is it a this line? Yeah, it's horizontal because y always has to be 4. So right here it is. And then we are shading on that one below. On our yellow one, we are shading above. And then this one is a straight line again, isn't it? Isn't it this type of line? So x value is greater than 0, so that would be to the right, wouldn't it? So my shaded region is right here. Okay, you guys are doing good. Okay, now we just have to see bounded versus unbounded. So that's the big chunk of the lesson right there. That was the easier portion. So bounded versus unbounded solution sets. Bounded solution sets have vertices, meaning corner points. It's restricted to a certain area. If you can basically, guys, if you can draw a big old circle around your solution set, it's bounded. If it's unbounded, it's an infinite solution set. So with this first example right here, would this be considered bounded or unbounded? Yeah, bounded. Here's my solutions right there and only right there. There are vertices or corner points. All right, and then right here would be unbounded, because you can't circle it. Unbounded, bounded, bounded. Okay, you guys get that. Now, why that's important is because when we get to story problems, you guys, it would make sense to have what's called feasible regions. Meaning, in the context of a story problem, let's think about this. If we were to solve a system of equations in a story problem here, here's our XY chart. Don't we input positive stuff? Always into story problems, right? Usually in real world settings, can you input negative money? Does that make sense? You're not going to input negative. So you're only going to care about the x values being greater than 0. Now, when you input in a real world problem, if you input some positive money, you're going to get out positive money only, correct? So usually in a story problem, your feasible region is always input is positive and output is positive. So usually we're always in quadrant 1 for story problems. So that's called a feasible region. It just means applicable region in context of the story problem. So let's set up this story problem here. All right, this is where it started to go downhill in first hour. So I need you all to focus really hard with me for a second because it's going to go so much smoother. I just have this feeling. Okay. A factory produces 2 agricultural pesticides, A and B. For every barrel of A, the factory emits 0.25 kilograms of CO and 0.60 kilograms of SO2. For barrel B, it emits 0.5 kilograms of CO and 0.2 kilograms of SO2. Pollution laws restrict the factory output of CO to a maximum of 75 kilograms and restricts the output of SO2 to a maximum of 90 kilograms. Now in part A it says create an inequality that would represent an equation that will satisfy our pollution laws. So think about it. This factory is outputting these in this factory, right, they're doing 2 pesticides and they're both putting out like toxins into the air, correct? And it is illegal at a certain point to be putting out a certain amount of toxins. So let's set up an inequality that would help us know an okay amount of toxins to put in the air. So you would draw your little squiggly. So now what are we going to call x and y? A and B, okay, so x, y. statements out. There's two true statements here. Okay. So what would be a true statement here? So 0.25 x though? Yep, x plus, you guys, are we doing CO with CO? Because it's, right? It's okay. So we just got to be careful here. This is where we messed up in first hour. So guys, like, CO is going to be with CO so that we can look at total CO output. Does that make sense? So this is 0.25x plus 0.5, and that's coming out of y's, correct? Everybody, isn't the 0.5 coming out of the y barrel? Okay, and that needs to be, because this is all CO, needs to be less than or equal to 75. Does that make sense? We had an issue last hour with that. Are you guys sure you're good? This was CO for barrel A, CO for barrel B. Okay, then the next true statement. 0.6x plus 0.2y needs to be less than or equal to 90. Now, because this is a story problem, the feasible region would be, well, we're only going to input positive and get out positive. So x values need to be greater than or equal to 0, and then y values need to be greater than or equal to 0. All right, so now in part B, it's really easy. It says, will it be legal for this factory to produce 100 barrels of A and 80 barrels of B? So what would I do with 100 and what would I do with 80? Plug it in. So wouldn't I plug in 100 here? 80 here. If it works here, we're good. But now we got to check this one as well, right? And system means it's got to work in both. So then I'm going to plug in 100 here, plug in 80 here. And if it's a true statement for both, it is in the system of equation. The systems of inequality solution set, right? I'd rather solve this one by plugging in than graphing it and seeing. So you would plug it in, and you would see that this is a true statement and this is a true statement. Therefore, yes, it is still legal for them to produce 100 barrels of A and 80 barrels of B in a day. Make sense? Or in an hour or whatever it was. Okay, cool. It works for both. So let's move on to our next problem. Okay, now this is still really easy here, okay? We're actually doing, this is so much smoother than first hour. Okay, so it says, this is what's called linear, quote, linear programming. All linear programming is, guys, is given a graph or information and a shaded region with a solution set. Can you see the solution set here? What it is you're able to tell from this solution set maximum and minimum input and output. So, if you look at this, guys, the maximum and minimums are always going to happen at the vertices. So what you're going to do here is find out all the vertices of intersecting of the solutions. So my first vertice is over a half, up a half. I would write that down. A half, a half. Now my next vertice, it doesn't matter the order though. Over 1 up 0 is a vertice. Then over 4 up 0 is a vertice, right? And then over 2 up 2 is a vertice. That's what's entrapping this area of solution. Now the question is, which one, those are the solutions in here, right? So these are the extremes of the solutions. So it says right here, find the maximum and minimum values of the given objective function on the indicated feasible region. So they gave you that n is equal to 1/2 x plus 1/4 y plus 40. It wants to know which one of these will produce the max and which one will produce the minimum. So everybody, what I want you to do is take your calculator. We're going to plug in a half, plug in 1, 0, plug in 4, 0, plug in 2, 2, and then we're going to write down what each thing came out to be. Right here, plugging it into our equation. So I'm going to take, somebody else take, I'm going to take 1, 0, because that's easy, and you guys are awesome. So you're going to take these ones. Somebody take a half, just bite the bullet and take the 1/2, 1/2. It's really not bad. Yeah. Okay?
4, 0 is 43.
Okay. Okay, so now do you guys see how we can see maximum and minimum values? Well, all the other XY points fall inside of those in that region. So what was our maximum? 4, 0. Produced the max. amount of whatever this is. It didn't put it into context for us. That's fine. What was the minimum? 1/2, right? And that would be the lowest amount that this story problem could input, right? So that's the starting point of the solution set. So still pretty easy, right? So even on the review, they give you a picture and they give you an equation. With these linear programming ones, they're always going to give you an equation and a system of inequalities, and then they're going to say find a maximum or minimum profit, find a maximum or minimum amount of toxins you can put in the air, find a maximum or minimum, and then you'll just use these vertices to plug in to find that answer. Okay, so let's do this one. It says find the maximum and minimum values of the given objective function on the indicated feasible region. So do you guys understand that we're not using this for anything but other than finding what the max or min is? This is like, here's our profit equation, and then here is the system of inequalities. So we would graph this, so just quickly, a sketch here. So we would get this into y equals mx plus b, so y is less than or equal to negative 2x plus 10. And then let's just do this one too. So we subtract 2x, so then I have 4y is less than or equal to negative 2x plus 28. Then don't we divide by 4? So then we have y values less than or equal to negative 1/2 x plus, isn't that 7? Okay, cool. So now let's graph this. So up 10 and then down 2 over 1. Oh, wait, down 2, wait. Oh, yeah. Down 2 over 1. Yep. Down 2 over 1. Down 2 over 1. Down 2 over 1. Okay. Now, where's the feasible region here? X is greater than 0, y is greater than 0. So I'm from here to the 10, right? That's the feasible region for this. Okay, next one is graphing this. So I'm going up to the 7, and I'm going down 1 over 2. Down 1 over 2, down 1 over 2, down 1 over 2. If I was to connect this, great. Now aren't we shading below both of those? Below. So here is my feasible region, everyone. So now how would I find the max or min? Yep, just plug in the vertices. So we have a vertice of 5, 0, 0, 0, 0, 7, and then we actually need to know the intersection point here, correct? The intersection of these lines. Now everybody listen to this part because this is what people get confused on in the future. What if you couldn't see exactly where they intersect and you had to use some math to find this intersection point? Well, aren't the lines equal at that point? So you would take this line, set it equal to this line, and then just use algebra to solve for x. Does that make sense? Then you're saying, when does this line equal this line? Then you'll find x, and then whatever x is, you'll plug it back in to solve for y. So we can see what it's going to be. If we were to do the math, but we can see it very clearly. Where is it? Where's our vertice here? Is it 3, 6? Or is it 2, 6? 2, 6. So then we would just plug in those values and see which one comes out to be the maximum. Does that make sense? I don't want to have to actually do that part. Do you agree? Okay. All right. Oh, okay, we're doing good. Now here's the really harder part. They're oftentimes, and I just know, they're going to put one problem like this on here. This is the same idea. It's just they're not giving you, they're giving you all the information, but you have to write the inequality, and you also have to write out the profit function or whatever function they're asking you to do. So let's read this problem and let's go through solving it all the way because it takes a little bit of thought. So everybody don't zone out. Don't be like, okay, I can't do this, because you have to be able to do it. So everybody focus back in with me for another couple minutes. Okay, a shoe company makes 2 styles of shoes, Oxfords and loafers. 2 machines are used in the process of making the shoes, a cutting machine and sewing machine. Each type of shoe requires 15 minutes per pair on the cutting machine. Oxfords require 10 minutes of sewing per pair. Loafers require 20 minutes of sewing per pair. The company can only hire 1 operator for each machine, so the process is available for only 8 hours per day. If the profit is $15 for Oxfords and $20 for loafers, how many pairs of each type of shoe should be produced per day for maximum profit? Way a lot of information, right? So what you're going to do is you're going to set yourself up like an information chart here. And then fill it in. So we're dealing with 2 types of things. Let's start at the beginning. So Oxfords and loafers are two types of shoes being produced, right? So I'm going to make a little chart. Oxford. You would always with these make a little chart to help you. Loafers. Why can't they just say shoe 1, shoe 2, but whatever. All right, we have two types of shoes, Oxford and loafers. All right. Now, we're also told, everybody focusing with me, Davey, Crockett, you and him are flirting across the room. Stop and pay attention. Okay. All right. A cutting machine and sewing machine are used in the process. So guys, let's think, okay? Because this is kind of where we had a hard time last hour. Now think about it. For Oxford and loafers, there's going to be cutting involved of the shoe, correct? Cutting and sewing. Cutting and sewing. So cutting for Oxford, cutting for loafers. Sewing for Oxford, sewing for loafers. Now we're told the information. So it says each type of shoe requires 15 minutes per pair on the cutting machines. So what would I'd go to cutting. How much did Oxfords take? 15 minutes. And how much did loafers take? 15 minutes. All right, next one. Oxfords require 10 minutes of sewing. So we'd go to sewing in Oxford. 10 minutes it would take. And then 20 minutes of sewing for loafers. So really not that bad if you can fill in the chart as you go. Now let's keep reading. The company can only hire one operator for each machine. Now isn't there a machine doing cutting and sewing? Okay, so we have a machine. And it says that they're only available for 8 hours a day. So to do the cutting, it's going to be available for 8 hours. Agreed? For the sewing, there's another machine, but it's only available for 8 hours. Does this make sense to everybody? All right. So now, next thing it says, if the profit for Oxfords, so now I have Oxfords and how much profit are we going to make? They get $15 per Oxford shoe sold. And then we get $20 for each loafer shoe sold. Now it says how many pairs of each type should be produced per day for maximum profit. So now because of the word maximum profit, we know that that's the equation we set up first, okay? So let's set up a profit equation here. This company is going to get a profit. Think about it in real life. How much money are they going to make? $15 off of Oxfords, correct? $20 off of loafers. So we got to call one of them X, one of them Y, don't we? They're different things. We don't know how many they're selling. So our true statement is profit is equal to $15 for, what the heck, sorry. I need to not write on top of it sometimes. Sorry. So we're going to have 15x plus 20y, right? That's your profit equation. Now you don't use those for anything else. That's just for the profit equation. Does that make sense, everyone? So now we've got to set up an inequality here. So I'm going to do a little, and we're going to squeeze in our inequality. So what stood for X? Oxfords. Didn't we say Oxfords? So Oxford is X, loafer is Y. So think about it. This is all Oxford stuff, isn't it? So this gets an X, this gets an X. This is loafers, Y, Y. So now what would be a true statement? Yep, 15x plus 15y needs to be, yep, less than or equal to 8 hours, correct? It's okay to take less but not greater than 8 hours. Our second true statement is 10x plus 20y also needs to be less than or equal to 8. Uh-oh, we're in different times. One of them's in minutes and one of them's in hours. So we got to actually hurry and convert our equation real quick. We got to pay attention to that, my bad. Do you guys see what I'm saying? Minutes, hours. So would you rather convert the hours to minutes or the minutes to hours? I agree, minutes to hours. So 15 minutes in an hour is how much of an hour? 1/4? Should we just use decimals? Okay, so instead we're going to fix this to be 0.25x plus 0.25y is less than or equal to 8. Now let's do this one. Now guys, that would be 10 out of 60 minutes. That's 1/6. What decimal would that be? 0.6? 0.16. Is it repeating? Yeah. So we better just use 1/6 so that we're exact. So 1/6x and then plus, yep, 1/3 y. And that needs to be less than or equal to 8. Now, why do we say 1/3? Because 20 over 6 is 1/3. All right, so this is 1/4, 1/4, but it doesn't really matter. Okay, so now, because this is a story problem, isn't it also true that x needs to be greater than 0 and y needs to be greater than 0? Feasible region. Okay, cool. You guys are doing awesome. We're almost there. We're almost there. Stay with me. Because they're given, oh, sorry, let me move back up. So we were told that each machine can only be used for 8 hours. So the cutting machine and sewing machine are separate machines. And it takes 15 minutes to cut up Oxford shoes, and then it takes 15 minutes also to cut up loafer shoes. So like if there's, you know what I mean? So we're trying to figure out like, well, how many of these shoes can we produce? Right. Okay, so now back to here, guys. We're also just going to add in x needs to be greater than or equal to 0, and y needs to be greater than or equal to 0. Now, don't we want a graph so that we can see the vertices, so we can see the maximum profit? Yes. Now, let me tell you something. You trying to graph these story problems exactly is going to be way hard. So let me show you how to do a rough sketch, but it's still very, very accurate. So all you're going to do at this point is go like this. We know we're only in technically quadrant 1, so I'm only going to draw that one bigger. Does that make sense? We're in quadrant 1. That's what the x and y greater than 0 is. Now, if we were going to graph this, there's a couple different ways to do it. What I would do is, we're not going to do mx plus b thing. We're not going to do slope, because that would take us forever. What if we're at huge values? So what I would do is get it into y equals mx plus b, but then we're going to graph by finding x and y intercepts. Look, if you know a y-intercept and an x-intercept, can't you just connect them? Does that make sense, everyone? It's not going to be perfect. So let's go like this. Get this one into y equals mx plus b form. So I subtract 0.25x, so I have 0.25y is less than or equal to negative 0.25x, and then we have plus 8, guys. Now we're going to times by 4. That's the same thing because this is 1/4. That's why I'm timesing by 4. Does that make sense, everybody? Or divide by 0.25 is the same thing. So what we get here then is our y values are less than or equal to negative 1x plus 32. This is this equation written in y equals mx plus b form. Okay, now, yes. Oh, did I? Oh, no, because I didn't divide by a negative. So now from here, guys, this is how you're going to graph it. You don't want to have to go up 32, do you? Do you want to draw a scale of 32? No, trust me, some of them are 1,000. So what you're going to do is say, okay, I'm going to just make an XY chart, and all I need is 2 points. X and Y intercepts. So plug in 0 for X, what do we get out? Plug in 0, just calculate it. 32. Do you all agree? So over 0, up 32, I'm doing a rough sketch. I'm going to make myself a note. I went over 0, up 32. Now I'm going to graph plugging in 0 for Y. So that would be this. Y is equal to, we're just doing equal to, and then that's negative 1x plus 32. So subtract 32, negative 32 equals negative 1x. So doesn't x equal 32? They're not always the same. This one just happens to be. So I'm going to go like this and say, so we were over 32 up 0. Now I'm going to connect those together. Moving on to the next equation. So that was pretty easy, right? Then we'll go to the next one, get it into y equals mx plus b form. So I'd subtract a 6. So I have 1/3 y is less than or equal to negative 1/6 x plus 8. So then I times by 3, and I get y values less than or equal to, and I get negative 1/2 x. And then I get plus 24. So now you would just make an XY chart because we're doing a rough sketch here. Plug in x and y intercept. So if I plug in 0, what do I get? 24. So now look, according to your graph, shouldn't you be lower than that? The orange? So I'm just doing a rough sketch. So I'm going over 0 up 24. Labeling is key. Then if I plug in 0, everybody, that would be this. 0 is equal to, 0 is equal to negative 1/2 x plus 24. So I subtract 24, negative 1/2 x is equal to negative 24, then times by negative 2. So x is equal to 48. So now think about this, guys. When you draw this in, isn't 48 past the 32? So out here, and I'm going to label it 48, 0. So when I connect that, it's going to be like that. Now there's our feasible region. We're done. We can see our feasible region. So now we want to know maximum. So we would do all the vertices. Now look, we know this vertice, 0, 24 is a vertice. Isn't also 32, 0 a vertice? Now we run into the problem that I was talking about a second ago. We don't know that vertice right now, but how can we find it? Set the lines equal. So this line equals this line. So you're just going to say negative 1/2 x plus 24. When does that equal negative 1x plus 32? So then you would combine your x's. So I'm going to add x. Isn't that 1/2 x? Subtract 24. So what do we get? 8 times by 2, 16. So we know that we're over at 16. The question is, how high up are we at? So now plug in 16 back into here or here. It won't matter. So if I plug in 16, y is equal to negative 16 plus 32. Don't we get 16 again? They won't always be the same. It just happens to be. So you have your 3 vertices. Let's see which one gives us the maximum profit. So everybody, right, here's your profit equation. See, I know, these problems are long. Now we would plug in each problem. We plug in 0, 24, calculate it. Plug in 16, 16, calculate it. Plug in 32, 0, calculate it. Now I don't need to plug in 0, 0, do I? It would not be maximum profit at 0, 0. All right, so then when you plug in 16, 16, okay, let me just tell you. Can I just tell you what they calculate to be?
I think if I misread that,
Because we said, when does this line equal this line? And then solve for x. And then once we know x, we have to plug it back in to get y. Does that make sense? Okay, so now when we plug in, look, if I plug in 0, 24, guys, it calculates our profit equation. It calculates to be $480. When I plug in 16, 16, the profit function calculates to be $560. When I plug in 32, 0, the profit function is $480. So what's the maximum? 16, 16. Ooh. So you'd say they need to do 16 Oxfords and 16 loafers to make the maximum amount of profit. Holy shnikes. See, it just takes a long time. It's not that it was like really super hard, right? It is kind of hard setting up, so that's the hardest part. Okay, so the question is, you guys did awesome with that. So much better, so much better than what it went for me last hour. The question is, do you need one more example or do you not need one more example? Maybe just setting it up. Because then after that, graphing it. Okay. Yeah. Let's see if we can set this up. Okay, a housing contractor has subdivided a farm into 100 building lots. So we have 100, I'm just going to write that down, 100 building lots that we can build on. Houses we can build on. Now it says there are 2 types of homes, colonial and ranch style. All right, a colonial requires $30,000 of capital. So $30,000 of capital. And, you guys read because I'm like way up close. So profit is, and still under colonial is, how much money will they make off of that? 4,000. Okay, cool. Keep reading. So I'm lining it up, right? And then 8,000. Okay, next information. So the contractor has this much money, 3.6 million, in what? In capital. Now what's it asking us? So now, aren't we setting up a profit equation again? That's where you should start. So you'd say, okay, what is my profit statement? Profit. Isn't this the money that this person's going to get once they build this, right? So you're saying that they're going to make 4,000 X's plus, 8,000 Y's. Now those are only used for your profit equation, so they're gone now. Does everybody see? Okay, so let's set up our true statement then. Okay. Now, what would be, so you called these X's, didn't you? And you called ranch Y. Okay? So now, next true statement. Capital, capital, capital. Isn't this all capital? So you would say Okay, 30,000x plus 40,000 y's needs to be less than or equal to 3.6 million. So that would be 3,600,000. That's 3.6 million. It's less than or equal to, right? The person can always spend less than their designated capital, but if they spend more, they're fired. Okay, we gotta have another true statement because it's two variables. X stands for the number of colonial houses. Ranch stands for the number, Y stands for the number of ranch houses. Yeah, 100 lots, isn't there? 100 lots. So our next true statement is X plus Y equals 100. Okay, good. Now, technically, we're going to do less than or equal to 100 because they could build, I guess, less houses technically, but it is going to be equal to. So less than or equal to 100. All right, good. Then what would we do from there? And then also, right, X has to be greater than or equal to 0, Y has to be greater than or equal to 0. Then from there, wouldn't you just do what we just did a second ago? Graph a rough sketch. Yeah, and with the rough sketch, you guys, make sure you just do X and Y intercepts, or else it's going to be a nightmare. Then there's going to be an intersection point of the lines. How did we find those? So you got it into Y equals X plus B, and then you set each of those equal to each other, right? And then solve for X. Once you know X, you got to plug it into one or the other to find the Y, and then there you go. And then you plug it into your profit equation. Oh, yeah, that's the end of the lesson. See, that went smooth. It wasn't as bad as you guys thought it was going to be, huh? It was kind of long, and those story problems kind of drag on, but, you know.